Today we're going to cover Chapter 5, Section 1 and 2. Starting with Section 1, Organizing the Elements, we're going to talk about the man who first created the periodic table, Dmitri Mendeleev. He lived from 1834 to 1907. He was a Russian chemist. And he was the very first to arrange the elements into rows in order of their increasing mass. Now, our periodic table today is arranged based on a set of properties that repeat from row to row. So they are more in columns than they are rows. Now, Section 2 is specifically talking about today's periodic table. So what you see in my classroom up on the wall, it's a little outdated. We're up to 118 now. But we're going to specifically talk about what goes into making the periodic table in different groupings. So periodic law states that the pattern of repeating properties makes up our periodic table. So in today's periodic table, all of these elements are arranged by the number of protons that they have, or by increasing atomic number. So no longer by their mass, but now by the number of protons they have. Periodic table also has what's known as periods and groups. A period is the row that you see, and each row has a different number of elements in that row based on how many energy levels are available for that row. We also have groups, those are the columns, and each group will have a similar electron configuration. We talked about that from Chapter 4. And then a couple of hit and miss reminders. Atomic mass, a value that depends on the distribution of an element's isotopes in nature and the masses of those isotopes. So for example, the mass number that you see for carbon-12, which is 12, is actually an average of all of the different isotopes and radioactive pieces of carbon atoms that there are. It is measured in what we call AMU, or the atomic mass unit, and 1/12 of the mass of a carbon-12 atom, so they've used carbon-12 as their sample. It's the most readily available. That is your AMU, or your mass unit. So 1 AMU is for hydrogen because it has 1 as its mass, which is 1/12 of 12. There are 3 different classes of elements. We have metals, nonmetals, and metalloids. The metals are anything that's a good conductor, and all of these are solids at room temperature except for mercury. Mercury is actually a liquid. And if you look at the periodic table, mercury is labeled as Hg. All of these metals are also malleable, and they are ductile. We have what's known as transition metals, and that's all of your metals that are in that rectangle box kind of in the center. So they form a bridge between what we have on the left and what we have on the right sides of those tables. And what we're really going to be dealing with for this class are what's on the right and left-hand sides. So copper, silver, all of those are examples of what you can find in the middle. Non-metals, these are poor conductors of heat. Most of these are going to be your gases at room temperature. So think about oxygen, nitrogen, hydrogen, helium. All of those are non-metals. And then we have metalloids. Metalloids are kind of half of a metal and half of a non-metal. So they can be a conductor. They're just not very good at conducting unless they're at a specific temperature. And there's actually kind of a zigzag shape right in between the transition metals and right in between the non-metals of these metalloids. We also have what's known as period variation. So as you move from left to right on the periodic table, elements become less metallic and more non-metallic. So all of your metals should be on the left-hand side. All of your non-metals should be on the right-hand side, with the exception of hydrogen. And that's it for today.